Good morning, and it's crafting time again, folks, but we're doing a little something different today. We are going to do actually a science experiment. And this is week 7, part 2 for summer reading program. By all means, if you haven't signed up, please go ahead and come down and we will sign you up and get everything you need to start your fun summer projects. All right, so what we're going to do, this is milk, I promise. Brought this in from home. This is 2% to be precise. And now what this does, what we're going to do is we will need milk, a small bowl of any kind. We are going to need food coloring. And we are going to need Dawn dish soap. And we are going to need Q-tips. Now, if you need any of these items, please let us know. We will get it for you as quickly as possible so you can enjoy this experiment. Otherwise, you can just follow along and enjoy the video for today. Now, what we basically know is that milk is mostly water, but it also contains vitamins, minerals, proteins, and a little bit of fat molecules. Now, it's suspended in the milk itself, the water part. And the fats and proteins are sensitive to any kind of change in their surrounding. And the secret of the bursting colors is the chemistry in the soap. So we are actually, I'm going to use blue so you can see it real good. And the dish soap is a bipolar characteristic. It means it has one end that's polar and non-polar, and one is polar. It weakens the chemistry bond that holds the proteins and fats in the solution. And the soap's polar side, which is called the hydrophilic, water-loving side, and it dissolves in the water. And the hydrophobic water, fearing water, it attaches to the fat and gobbles up in the milk. And this is when the fun begins. Now, the molecules of fat bend, roll, and twist. I'll show you what I mean. And this is why we need the food coloring, so we can see the reaction going on. And I'm trying to get my Q-tip out. And we're going to put a little soap on our Q-tip. You don't need much, folks. And this is where I'm going to put it on the other side too, just in case. Now, does it have to be done? No, it does not. But this is where the dish soap is going to come in. And we're going to dip it on down. Whoa, look at that. And this is just because of that, the soap and what we were talking about with the fats and the proteins, and how they're very sensitive to the change of their environment. Now, the molecules of fat bend and roll and twist in all directions as the soap molecule races around to join up with the fat molecules. You can do it a lot of times too. During all this, the fat molecules are doing basically their gymnastics in the food coloring. That's why we need the food coloring, so we can see the reactions. They're bumping and shoving each other and providing an easy way to observe all the invisible activity. As the soap becomes evenly mixed with the milk, the action slows down and eventually stops. So try adding another drop of soap to see if there's any more movement. If so, you discover there are still more fat molecules that haven't found a partner at the big color dance. And then you add another drop of soap to start the process all over again. And we can do this a lot. Now you can see it's starting to slow down. Let's add some more soap to it. We even have another side to it. So we'll start that on that side. Ooh. And this is why I have plastic. I got it dribbled all over it. Oop. See how it's slowing down? That means there's a lot of soap in there. Whee! And that is our science experiment, and how soap disperses the fat in the milk. Until next time, we'll probably have another science experiment for you next time. So until next time, that is the summer reading program event for the week. There's a second one coming up too, so keep your eyes open for that one.